Hey gang, I got a real nice set of Kruppe squares here. Just took the cages off to clean things up a bit, and as usual, I discovered something surprising to me on the left pedal here. I see this all the time actually. I don't know why it surprises me anymore, but this spindle, when you would feel it, you could feel it move this way. That's an exaggeration of how far. It was maybe about a millimeter. I have to do the math. Not even a millimeter, maybe it was a fraction of a millimeter, but you could feel that. And that's actually the way they made it. I find this stuff all the time. Fancy hubs, bearings and stuff like that. The left one, I mean the right one here, it's quite perfect. And both pedals spin like crazy. They spin really good. But I decided I'm going to fix that. And the deal on these are, what causes that is that on these, this is the earlier spindle design where they taper down to 3/8 right at the outboard bearing, whereas the modern ones taper right after the big bearing. They step down to the 3/8 dimension. So on the modern ones, the critical dimension is from this shoulder to the end of the spindle. On this one, the critical dimension is from the shoulder to this shoulder. I like this design because it sort of splits the load between the bearings. In theory, it's pushing on both bearings at the same time. When you have just the one that's shouldered right here, it's really only pushing on one bearing or the other when you're putting loads on axial loads on the pedal. So the reason why this pedal has a problem, it's a caliper, is that if you measure out, and I can't do it with this, but if you measure out that section right there and compare it to the proper segment inside of the housing here. So in other words, from that outside shoulder, the inner shoulder, to where the bearing rests down there, it's a little bit, it's too long. And when I say too long, I mean 0.006 inches, or what is that, 0.006 of an inch too long. That's a really tiny amount, but it's enough that you can feel that axial play. So I'm going to fix it. In fact, I was going to mention also that when you measure one of these pedal bodies from here to here, you get like 1.496 on this one, 1.496 inches. On this one, you get like 1.49. So there's that 0.006 again. And to fix it, I'm going to put a shim behind the bearing. That will require that distance to be a little bit longer anyhow. This shim is too thick. It's 0.02 inches or 20 thousandths. This one doesn't say on the label what it is, but I'm measuring 0.055. So fortunately, I think this is just about perfect. So that's what I'm going to use. I'm going to stuff it behind the outboard bearing right there. The way I'm going to do it is just really magic, right? I'm just going to drop it in the hole. And then I'm going to put the bearing in there. And I'll do this side because I only have 7/8 inch diameter shims, and that shim it would still work there, but I'd rather do it where it's really a proper fit, because if you see these things, it says 0.873 inches versus 7/8 inch hole, which would be 0.875. So it's a really good fit. I mean, it's made for the purpose. There's nothing new manufactured high-speed pumps, jet engines and all that jazz have shims behind the bearings, and that's actually how all these different pedals should have been made. But if you see the picture of the Hutch pedals from back in the day, there was a pile of about 500 pedals there, and a lady on a workstation, she cannot sit there and individually shim every one of those. So they just made the parts to spec as close as they could and threw them together. You got what you got. So let's see how this goes.